Hello everyone, welcome to another tutorial of machine learning with Python tutorial series and markers for linearsciSQ.com. So in the last video we discussed about how to use linear regression to predict the revenue of a company by doing some advertisement on some social media platform. And in this video, instead of using linear regression, we are going to look at another example in which we can use logistic regression, which is a non-linear regression function, to example in which we want to predict whether a person will leave a company or not based on certain independent variables. So without further ado, let's look at some of the presentation that I've prepared for logistic regression. And so logistic regression or logistic model is defined in Wikipedia as a model that predicts the probability of certain class of event that will happen, such as pass or fail, win or lose, life or death, or healthy or sick. So if you notice, these outcomes are binary outcomes. That means they are either true or false. So what happened in logistic regression is that you can put in different kind of independent variables, whether it's continuous or categorical, but then the outcome is always a categorical outcome in the binary form. So in our example later, we will predict whether a person will leave a company or not, which is will leave or will not leave. So you just have to remember that logistic regression is a nonlinear model that will predict the outcome in terms of binary outcome. And then in real life situation, dependent and independent variables, they are not always linearly related. And for example, the growth rate of a population in a country, or maybe the sales rate of a new product in the market. So in such a situation, we can't use the linear regression, and therefore we may want to use logistic regression, which is a non-linear regression model. So the regression model is probably say to be non-linear if at least one of its parameters or x appears to be non-linear. And in statistic, logistic regression is one of the most useful and commonly used form of nonlinear regression. If you look at the example here, the car value is depreciating over the year. If we were to define it in the equation, for example, C1 plus C2 multiplied with the number of years after the purchase, we may not be able to predict the price of the cars accurately after a certain number of years. But then if we were to use another equation such as C1 plus C2 exponential negative C3 multiplied with the number of years after the purchase, which is a non-linear equation, we can probably predict the price of a car after a certain number of years better. So you can see that in certain cases we have to use different kind of functions for the purpose of our prediction. So in the second slide, we can also look at the application area of logistic regression in other areas such as loan acceptance. For example, banks will use logistic regression to predict whether a person or a customer will accept an offer loan or not based on their previous behavior. Or the bank can also use logistic regression to predict whether a customer will pay back the loan or will not pay back the loan. And some airlines, they are also using logistic regression to predict whether an airplane will delay or not. So these are some of the application area in which logistic regression is used. And without further ado, let's dive right into our example today. So if you have been following along this tutorial series, you will notice that I'm using Google Colab, which is a free software. So if you have a Google account, just go ahead to Google Colab and then create a new notebook. Otherwise, just please go ahead and create a Google account so that you can use this free software. And then so the first thing that I want you to do is to go ahead to these two link to download the data set that we are going to use today. And the first one is a train data set, and the second one is a test data set. Later on, I'm going to explain a little bit more about what is this dataset about. So yeah, before we dive right into write some code, I would like you to look at logistic functions. So we have been talking about logistic regression, but what is really inside the logistic regression? So the entire logistic regression is basically defined by logistic function, which is basically a S-shaped curve or a sigmoid curve, and then the outcome is always a 0 or 1, or which means it's a binary outcome function. So whatever your input, whether it's independent variables or dependent variables, when you put into logistic function, the outcome is always a binary outcome. So if you want to look and understand more about this function, feel free to Google about it to understand how this formula is derived and what each parameters are referring to. And the next thing that you would like to look at is probably the statsmodel.org, because in the last video we talked about how we can use the statsmodel.api to do some statistical model for our linear regression. And in the last video we were using ordinary least square for the linear regression model, but then in this example we're going to look at regression with discrete dependent variables. If you go to this regression with discrete dependent variable, you can look at the example that they use, and then you can also look into Logit function, which is the one that we're going to use today. So I'm going to show you how to use it later on. If you feel like you want to understand more about all these different models, feel free to go to this link. I'm also going to put this link in the description of this video. And just come back to our notebook and then create a new cell. And the first thing that we always want to do is to load in the library that we want to use, and same as linear regression, we are going to also load in NumPy, Matplotlib, Seaborn, and also pandas. So to do that, I will just copy and paste the code and go ahead and run this. So now we have import pandas and NumPy. We also have Seaborn and Matplotlib for our visualization later. And then also we initialize the Seaborn. So the next thing that we want to do, once you have downloaded the data from these two links, please save it in your folder, and then we're going to load in the data into the notebook so that we can use them. So to do that, let's say from Google Colab import file, and then uploaded is equal to files.upload, and then go ahead and run this, and then it will allow you to select the files that you want to upload to the notebook. So I'm going to select test and train data. So after the file is uploaded, it should appear in your file folder here. So since I have uploaded 2 times, I'm just going to delete one of them. Oh, I will just leave it. Yeah. So after you have successfully uploaded the files, the next thing that you can do is to read in the data file into data frame. So to do that, let's say this one is step 2. Load the data, and then df is equal to pd.read_csv, and our data is turn over train.csv, and then df.head. Cool. So we have successfully loaded in our data, and then we can see that we have some columns. So the first one, you have if the name is the name of the person, and this data set is actually about employees in a company which have or have not leave the company. So if you look at the left column, if it is 1, it means that the person has left the company. If it is 0, means the person have not left the company. That means he or she is still working in the company. So we also have other columns, which is satisfaction level, and then we also have last evaluation, which means the score of that person in the last or recent evaluation. We also have number of projects that the person was undertaking, and then average monthly hours that the person has spent in the company. Also, we have the experience in the company in years. Work accident, if it's 0 means the person has never faced a work accident before. If it is 1, that means the person had faced a work accident before. So promotion last 5 years means that whether a person is promoted in the last 5 years or not. 0 means no, 1 means yes. And then we also have different roles in this company. For example, sales. Later we're going to look at different. If you want to look at more about the roles and salary, the salary is low, medium. We also have high, so we can also see the detail. Yeah, we also have other roles like support, technical. So if you want to look at more about this data, which is the next step that we want to do, is to explore the data. And to do that, we can say df.info. Yeah, so you can see that we have 15,000 entries, which means 15,000 rows in this data set. And then we also have different columns, and then the satisfaction level and last evaluation belongs to float type, and then other variables belong to integer type. But then for row and salary, they are actually belongs to object type, which we don't want to use object type in any regression because the model is not able to interpret it. The model will not know what is support, what is technical, what is low, what is high. We have to transform it into something that the model can understand, which I have already showed how to do that in the last video, in which we use a function for scikit-learn, which is called label encoder, to transform it into a numerical form so that the machine can use it for the purpose to treat it as independent variables for the purpose of predicting the outcome. So the outcome of our logistic regression will be 0 or 1 for the left, which means that we will predict whether a person will leave a company or not. If the logistic regression says that give outcome of 1, means that it predicts that a person will leave a company. If you give an outcome of 0, it means that the model predict a person will not leave a company. So we're going to do that for the test data set after we have trained the model. But for now, we just want to explore a little bit more about this data before we train the model and do the prediction. So the next thing that we want to do, if you want to understand more about this data, for example, the statistical value, you can also run df.describe, so that you can look at some of the minimum and maximum value for each columns, and then the interquartile range, first quartile, third quartile, and the standard deviation, and so on. And then yeah, I guess I want to stop here for this video, and then in the next video we are going to do more visualizations. I'm going to plot some heat map and also some distribution chart to get you more familiar and have a better understanding of the data set. And after that, we will train the model and we will do some prediction from the test data set. And if you like my video, feel free to click the like button. Otherwise, I will see you in the next video.